Everyone. So today we're going to go over one of the final topic in exam FAM, which is all about calculating reserves, calculating premiums, and how to go about calculating the present value of future benefits and present value of future premiums. So we're going to talk about a bit about that. So if we look at a time diagram of a person aged X, let's say it's a whole life continuous or a discrete insurance policy that they have. And this policy pays death benefit as a whole continuous life insurance. So the death benefit at any time that they die, right? The end of the year, in the case of discrete, they will pay at the in the case of discrete, they will pay at the end of the year of death of $1. So if they die at 4.2 years, the end of the fifth year, $1 will be paid. So let's just label these. And let's say the premium of P is collected. P is collected. Now, one thing to note is we know that T of X is the random variable representing the future lifetime of person aged X. V to the T of X is now the present value of the random variable of the future death benefit. So if they die at 4.2 years, they will get the benefit at 5, V to the fifth. That's our present value. We denote this as this, and we can make this discrete by not including a bar. And if we include a bar, then that is referring as a continuous whole life insurance policy, or referring to the fact that at the moment of death is when the $1 is actually being paid. Now, if we look at an annuity, or in the case of premiums, which is an annuity due, we see that the formula here is 1 minus v to the tx over the force of interest in the case of continuous. So that is the present value of this sequence of payments or an annuity due. And so we have, from the insurer perspective, we have the premiums that are being collected, that what they are receiving, and what they have to pay out, which is the death benefit. In this case, we're saying that it's a whole life continuous or discrete insurance. Now, there's many different types. So there's endowment insurance, which is how after a certain point, let's say 10 years, the death benefit is actually just b to the 10th, even if they survive like 15, 20 years. So for example, what I mean is if it's an endowment, we have 1 all the way to 10. Right? So if they die any point here, the present value of the death benefit is going to be v to the t. If they die at any point after 10 years, it's going to be v to the 10. So that's what we mean by endowment insurance. Now, if we refer to this as term insurance, if we say term insurance, what that is referring to is that if they die at any point after 10 years, then that is going to be 0. That is going to be 0. And if they die any time between 1 and 10, that is still going to be v to the t. So there's different insurance types that we can model. When we think about the present loss of the insurer from the insurer perspective, we see that loss, which is a random variable, is going to be equal to what the insurer receives, so the premium amounts, so PA, P times A, which is the annuity, X, minus what they have to pay out. So the death benefit, and assuming it's just $1 at the moment of death, it is AX. So this random variable represents the insurer loss. It is what the insurer receives in terms of premiums minus what they actually have to pay out in terms of the death benefit, discounted. Discounted. So obviously this is v to the tx, and this is 1 minus v to the tx over force of interest if it's continuous. Same thing as 1 minus ax over force of interest. Now, one of the things here is we assume typically the equivalence principle, which is the entire idea that the value of the present value, the expected value of future benefits is equal to the expected value of future premiums, right? Which states that initially when we start, we are not starting off with a loss or a gain. We're starting off equally, right, at equivalence. So that is the equivalence principle. Typically, this is assumed. It will state in the problem description that assume equivalence principle, or the premium is calculated using the equivalence principle. So this is something that we can directly either get from the problem, or if there is a wording, let's say net premium, or some particular wording in the problem that can also, and we can also infer that it is actually equivalence relationship. So again, if it's not equivalence relationship, then we can't really calculate P by equating these two. So if it is, we can calculate the premium that we would need by just doing AX over lowercase ax, right? The present value of the death benefit over the present value of the over the, of the premiums. Right? And so premium of $1. So that's how we get this. And again, this is a general form for any insurance type. So endowment term, really you want to stick to the basic principles of getting the present value of the future benefits, getting the present value of the future premiums, equating them, and then solving for P. We can also get the variance. We can also get the variance of the loss variable. So we know that the variance of the loss variable, we know that the loss variable is PAX minus AX. We know that PAX refers to P times 1 minus AX minus AX. And when we factor this out, what we get here is we get variance of P over force of interest minus P over force of interest AX minus AX. We get variance of minus AX right? And we can simply calculate this as this squared times variance of this. So long story short, if we want to calculate variance of a present loss variable, then we were able to get it through just by taking the variance of our formulaic expression here, making sure to factor out the constants. Now, there is also gross premium, which refers to the fact that in addition to just paying out the death benefits, we also have additional operational expenses to also pay out. And so this is typically in the problem given to us as 0.5% of the premium for the first year and then 10% of the premium for the remainder years after the first year. So that counts under what the insurer has to pay out, right? Those are the expenses. And essentially what we're doing is we're equating under equivalence principle, we're equating the cash outflow to the cash inflow. So essentially you take all of your premiums and you're equating them with the death benefits plus the expenses, right? Plus the expenses, plus the expenses. Right, so this is if you're able to understand this general idea that you're equating cash outflow to cash inflow, equating the premiums, which is what the insurer receives, to the death benefits and to the expenses, which is what the insurer gives out, you're able to equate that. That's one of the fundamental concepts in getting the premium amount, getting the gross premium amount we do have expenses. So that's a very critical foundational concept. And then we also have the idea of reserve, meaning that, yes, even if it is equivalence principle initially, we know that mortality rates are going to change over time. As people get older, they're more likely to die. And so insurers have to make sure that they put aside a certain amount or put aside what we call a reserve to ensure that they have enough to cover for those deaths when they do occur because as time goes on, there's higher likelihood that people are going to die, and so insurers have to make sure that they have a set amount or a reserve in place to actually pay out those death benefits. And so that's the entire idea of reserving. It's the entire idea of reserves. And so now, how do we calculate those reserves? Initially, the reserve at time step 0 is going to be 0, right? Because we've assumed equivalence principle. It's the difference between the premiums and the death benefits plus expenses. But as we increase our time steps to 1 and 2 and 5, as the difference between the premiums and the death benefits, if we don't have any expenses, that will be referred to as the reserve, right? What are we paying? What are we reserving, keeping to pay for those future death benefits? So at that point, you have to calculate what is the premium amount at time step 5. What is the present value of the premium amount at time step 5? What is the present value of the future death benefit amount at time step 5? And the difference between those is what we refer to as the reserve. So reserve, in short, is present value of future death benefits or future premiums, minus the present value of future death benefits if we don't have expenses. So that is what we refer to as the net premium reserve. Now, the net gross reserve is what we would have when we have additional expenses in addition to the future death benefit, in which we just layer in on top of the future death benefit, we layer on top the additional expenses. We also have, so that's the net premium reserve. We also have a way to get a recursive way to get the reserves at different time steps. What do I mean by that? At time step 5, we are going to have a reserve. Let's call it VT. At time step 6, we're going to have a reserve. Let's call it VT plus 1. Now, understand that VT is PAT, right, minus AT. Right? And then at VT plus 1, it's PAT plus 1 minus AT plus 1. Right? So it's the difference between the premiums and the present value of the future premiums, present value of the death benefit between each of these two. Can we come up with a recursive relationship between these two values? Reserve at time step 5 and reserve at time step 6. The answer is yes, we can. The main thing in understanding what this recursive relationship is identifying what happens between these two time steps. What changes, what stays the same. And what changes is at time step 5, we have the reserve from the previous time step that is referred to as VT. Then we add on to the reserve the premium. Then we have to accumulate this with interest. And now this new accumulated value can be used for two things. A is to pay out the death benefits for all the individuals who have died within that time period. And B is to set up the reserve for the next time step. So you're using this accumulated value of the previous reserve with the current premium, and you're allocating that after you've accumulated interest for a year or for the next time step, you're allocating that to two things. One is to pay out the death benefits for all those who have died within that year, and two is to set up the next reserve amount for the next time step. And so this is our first part, what we have accumulated for the next time step. And now what we will use this for in the next time step is if the individual dies, so the probability of death, we will pay out the death benefit, so B, whatever the death benefit is, plus probability that the individual survives. And if the individual survives, then that will be the next reserve amount, right? That will be the next reserve amount. And so this is the recursive relationship that is important to know. So that's, again, a high level of what I wanted to cover. But really, if you understand the main conceptual points here, then understanding the rest becomes really easy. And the main conceptual points here is that the insurer receives the premiums. They collect the premiums, they pay out death benefits, they pay out expenses. Their goal is obviously to maximize profit, and the way that they're able to do that, to make sure that they're not at a loss and to protect themselves, is by setting aside reserves. We calculate these reserves at different points within a time diagram through the difference of the present value of the premiums and the future death benefits. The equivalence principle states that at time step 0, the present value of the future death benefits equals the present value of the future premiums. We're able to calculate premiums through that equation by equating those two if we assume equivalence principle. Also, it's important to know the recursive relationship between the reserve amounts at different time steps. We also have additional expenses in addition to future death benefit that we can simply include into our equation just by thinking of that as another expense in addition to the death benefit. And that's really high level conceptually what you really need to understand in order to grasp a lot of the other concepts in this chapter or in this topic. A lot of the other nuances is that this will just extend to other insurance types, as I mentioned. So endowment, term, deferred, discrete, continuous. So it will be very easy for you to extend to those once you have a solid understanding of this foundational concept. So that's all. See you in the next video.